Welcome back once again, and here we are on episode 14 of our series on creating a custom programming language from scratch in C++, using tools such as Bison, Flex, Google Tests, and all sorts of stuff. And I'm Corey. Probably figured that out by now. And let's see. We had just implemented in the last episode the plus operator. And so we now have expressions that can have sub-expressions, right? Something plus something plus something. And that was good, but we need to do, I think, two things in this particular series today. And number one is we need to implement runtime errors. And that is, yeah, I think that's the simplest way to put it. Runtime errors. Why? Because things can go wrong, and we need a way for whatever code that's running to be able to communicate back to the calling code or calling function that there is an error and propagate that back up to whoever's called the error. Whatever code had called the error, or the end user, depending on how this is used. But in order to do that, we need a computed expression error. And we actually kind of already have it. Well, we have an error object, but we don't have the computed expression error. So we're going to go for that. And then the second thing is we're going to just refactor the code a little bit because some of these files are going to get really big. And so we're going to start breaking them up into smaller files, but then we have to do some work to our make file to make sure everything still gets compiled. And, well, let's just jump in. We have our code, and you know what? I made one change at the very end. That is, I realized it right after I stopped recording. And so let's just say, what is the change? Okay, in our garbage collected file. There we go. And what this is at the end of the last episode, I had created this OStream operator, and I knew it was a friend, but that means it should have been able to reach inside the GC and access its protected or even private members. And we've got this gc.ref. At least that's what I originally had, and it just would not compile, and I couldn't figure out why. And I was like, I know this is declared as a friend, and it hit me as the video from the previous episode. As soon as it was rendering down to the video that I would then upload to YouTube, it hit me, oh yeah, it's because when I was getting those errors, it wasn't in the correct namespace. It was declared in the Tang namespace, and then when I implemented it, I didn't put it in the Tang namespace, and so I was getting errors. And then later, in order to get everything to compile correctly and everything, I did, in fact, move it to the namespace, but I abandoned the approach that I had done. That is, I went to, as you can see here, don't know why my lovely tool is not working. There we go. What I had changed it to was just using the dump command, and I am now changing it back to use this ref dump. Okay, so simple change. It's the only change at this moment, so I'm just going to get commit -am and update. What is this for? Garbage collected. And how do I want to word this? I'm going to say to be safer with pointer access. Sure, why not? I don't know if that's the best wording, but okay, it gets the job done, and the compile works for this. Now let's get into our error thing. Now we have, I'm going to pull over our documentation page. We can make this a little bigger. I'm wondering if I should start numbering these with the episode number. Change it each time, maybe? I don't know. I'll think about it. But what was I going to do? Classes, and in our class list here, you know, we've got this error class. And what is it? It when we create it, so we can create an empty error, or we can create one and it has a string message and a location associated with it. And that's what I think we're going to do. We're going to have a computed expression error that will return this error message. That way we can send a location as well as the message, whatever that might be. So in order to do that, move that off the screen, minimize it, that way it's not in my way. So, okay, I'm in the correct directory. Let's edit. No, let's touch a file first. Not source. Yeah, source. And I think I'm going to start putting these in their own files. Do I want to do it that way? Yes. I think it will just make it easier to navigate. Computed expression error. And now computed expression error. And the question is do I want to start putting them, including their own .hpp files? Maybe that's going to make our compilation process a lot bigger, but I might do it. So error.hpp. So that means I'm going to touch. Why am I exiting instead of just opening it directly? Because for some reason it's been messing up my. And maybe it's only when I open the make file. Open the make file first, and then when I switch back and forth, maybe it's having some sort of problem knowing what to do with the indentations. But for right now, include / computed expression error.hpp. Computed expression error.hpp. Yeah, we can do this. If indef and why am I doing it that way? Simple, because there. That's faster than how I was doing it before. And we definitely need to #include the computed expression.hpp. And now namespace Tang, and we need to now stub out our computed expression class. Now I'm going to cheat. I'm going to steal some stuff from our existing computed expression. So I'm just going to edit our source computed expression. Oh, no, not source. Include .hpp. Fine. I will write this. You know what? I'm going to exit this. I think if I edit my vimrc, that wasn't right. Tilde slash dot vimrc, that if I set history, now computed expression error, and edit source computed expression, not source, include computed expression.hpp. Okay, there we go. And what am I looking for? Let's just copy the computed expression float. And I can do this by yank 25, B1. What is my command to open everything? I don't even remember. That's fine. Okay, represent a... remove everything else. A runtime error. There we go. And we will say error, construct a runtime error. And the parameter is going to be error I think I can just do this. Object. Okay. Oh, and we need to replace this error. I'm going to have a dump. We need a make copy. We need an is equal. An is equal. We're not going to have an add because you can't add together errors. Nope, we don't need that. We don't need that. And now this is the error object, and this is going to be a Tang error. That seems correct. evidently set history to not work like I intended, but again, I'll figure that out. You know what? I don't need the is equals. Yeah. And let's do what we should do now for the constructor. We need to just, oh, we're also location. Forgot about that. Wait, don't I do location? Oh no, that will be, it's not part of the computed expression. There's no reason for it to be, but it is part of the AST node. That's what it is. Okay. I'm remembering now. So let's get back to, there we go. And there we go. This one, the dump, what are we going to do? This is supposed to return a string, so let's just say yeah. Is it MSG? I think it is. We'll find out soon enough. And then what I do to make a copy. I mean, this isn't. Oh, but it needs to be a new. Okay. So return a new computed expression error. That's a copy of me. That should work. Watch it not work. Yeah, for some reason this I have a sneaky suspicion that this isn't going to work. But well, let's edit our make file. I'm going to do this in a different window. Oh, it's because that's why it's doing that. History is not the right command, and I don't remember what it is. ~vimrc. Okay. Now editing the make file. We're going to add an object. So error Okay, let's go down to our objects. Computed expression O. Record. Okay. That was simple enough. Okay, let's fix the compile errors. Oh, of course. Computer expression error.cpp line 5. Oh, in the HTTP file. I'm not in the HTTP file. Wait. No, that is CPP HTTP 21. We need to add that to the make file. Computed expression error should include that. All right. Computed expression error does not name a type. Why? Because it's in the namespace of Tang. And normally I do there we go. Of course I can't have virtual there. Doesn't serve any purpose. Oops, wrong window. I should just have this on watch. And it's right there. It doesn't like the override because override should not be there. Same way here. And has no member named message. Well, let's figure out what it's supposed to be. Oh, wait. I mean, yeah, of course we could do that, but... Oh! I spelled it out. Okay, so it's compiling and it's complaining about it doesn't have the is equals, which I took out. So let's do that. There we go. Okay, so it's compiling. That's always a good first step. And what do we want to do now? We want to let's use it, shall we? Yeah, so where are we going to do it? Let's start by looking in the source for just the generic computed expression. Okay. And, well, I guess it's all in here at the moment. To do, return an error. So make okay, so this does need computed expression error. Okay. Didn't mean to do all of that. Error. And now we need to pass in an error message, but we should be able to do this here. We're going to give it a string of now, it's not going to like that because my computed expression... Oh, no. It doesn't have a... I keep thinking it has a location attached to it. No, it doesn't. Is it that simple? It doesn't like that. So it doesn't know how to make an error that doesn't have a location. But we don't have access to an error. So, you know what? Let's... we don't have error open. That's fine. Edit the include for error. An empty error message. Location will be empty. It all compiles. Okay. Which buffer do we need to go back to? The computed expression, that's going to be 4. Another to do, return an error. This is, again, if the add doesn't work. I think I like what I had. Okay. That's gone pretty quickly. Let's go to the program. This is in source, program.cpp. Now it said that I do plan on pulling out so error is a pointer. AST is a pointer. Set a runtime error. Huh. That is not a runtime error. And let's say this is going to be EMPT, EMPTY. Empty. That's how you spell empty, isn't it? Yes. Are there any other to-dos? Push an error onto the stack. Okay. Let's grab it from the end. And it's not going to be that. It's going to be stack.push. There we go. And what is our problem here? It is that, so program check. The error. Not stack is empty, but well, I was going to say truncated. How about this? There we go. Opcode instruction is truncated. Oh, hey, that's what I had above. And we're going to have another one here. And this one is for this is where the stack is not enough values are on the stack. You can't say not enough. You have to say insufficient. It's programmer law. Insufficient stack depth. Sure, why not? Oh, of course. doesn't know what a computed expression error is. How dare it? Let's see. That's easy enough to do. We can pound include Did I just make a stupid mistake? Oh, it's push back. Of course. That means that I mess up on all of those. Probably. Push back, and there's another one. Is that at the end? Oh no. That may be all of them. Those do need semicolons. It just needed this slash as well. What do you not like about that? Oh. I know how I want to solve it. Let's just say stack dot push back, and then so it's just going to push it onto the back. This will set the result. It'll clear everything out and then return the correct value. Everything should compile. It does. All of our tests are still passing. That's always a good thing. And I'm just curious, where are we time-wise? 45 in. Okay. So we've got a couple changes. What have we done? We've added to the lib objects. That's fine. Added our computed expression error. Created an error message. Let's see. We've gotten rid of some to-dos, to-do statements. And let's see if there's any more. So we can say git grep -n, and that will tell us what line number. And if I wanted to know everywhere that had the text computed expression error, for example, that's where they are. That is computed expression.cpp line 30, line 63, line 96, or in program.cpp. That's a handy little thing. So now let's do a git grep -n. That means the line number, and just look for to do. And I guess there was a to-do list. I did not know that. But that's gonna... Oh, where is that then? Well, now I'm curious. Files, file members. No, I don't know where it generates that to-do list, because you would think it would be right here. Or is it in those? So where was it? It was in, for example, program. Did this have a to-do? Program.cpp, maybe. I don't know. I kind of want to know. That would be a nice little thing. I might start using to-dos more if that's lovely complicated. I would use them more if I can leverage them in that way. But as we can see here, it looks like we have caught all of the to-dos that are left, because that's just in existing documentation and we've taken care of that already. So makefile are include error, source computed expression .cpp, source program, and our two new files include computed expression error and source computed expression error. Sure, that's good. Now, what's the other thing I want to do? Well, I want to break out the computed expression float and computed expression integer. So let's just touch CLU float dot, that should be, this is include, so it's HPP. And we're going to do the same thing with integer. And then we will touch source computed expression float.cpp and integer.cpp. Simple enough so far. This is going to give me a bunch of compile errors, so we're just going to hang off on that. And I'm going to start off by editing include computed expression .hpp and also the source for computed expression. So that's those two. Now, if we add in here the include for computed expression, I want to do integer first, just mentally. Yeah, computed expression integer. Computed expression integer. And then also the float, the source for computed expression float, and I said source. There might be a way of reordering buffers, but I don't know what it is off the top of my head. So BD will remove it, and then now not source, include computed expression float. Now source computed expression float. Okay, and now I've got 1, 2, 3, 4, 5, and 6. Okay, so we're going to move the integers first. So let's say D26. To open everything is R. Okay. So ZR, well, it's supposed to. But that's okay. So what do we need? We need at file, close that off, and then if indef integer all right, and then this would be namespace Tang. What else am I forgetting? Oh yeah. Pound include computed expression dot HPP. There we go. Simple enough. Let's do the same for the float. For this one, we're going to we are in float.cpp. We should be in oh well, evidently I opened them in the wrong order, or maybe it just didn't fix. We need at file that pound if indef Tang computed expression float HPP okay. We need our pound include computed expression HPP okay. That looks like it's correct. Now, something else is not going to compile somewhere because I've moved out the integers. I know that. That's okay. We'll get this. Or moved out the, well, integers and floats. But so, two. And we're going to pull out, so computed expression integer goes all the way down to computed expression integer.cpp. And we're going to say and that's all I need to do with that. Let's go back and grab all of the computed expression floats, and that's going to be a dot hpp. Okay. Now let's do the make file. And by the way, this should no longer be maybe unused because it's not unused. Are we doing that on the integer as well? No, we're not. Nope. Okay. Yep, there we go. We'll just quit. And vim the make file. And now we're down to, oh, no, let's go back up to the top. So our lib objects are computed expression O and error. So the float there we go. Okay. So float and then integer. I think that's in alphabetical order now. So computed expression O relies on computed expression, and I think that it should also, I should be adding to all of these collected.hpp. And the same thing here. All right, and now I need 2 more. So this one, instead of error, is going to be float. I've got to change that here as well. I'm sorry, you know what? Let's see if I can do this. Is it /s/error/float/g? Other way around. Wait, no? Never mind. Evidently I don't know how to do it. I'll figure it out. Float. 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 Okay, and then integer. All right. Question is will it make now? Oh, that's why all the garbage collecteds that I added, I capitalized the G. And that was not smart. And I think now it's going to be in the source/computed expression. Let's do float first because what did I not do? I did not do using namespace std, using namespace Tang. That should get rid of some of the errors, and then the others are going to be in source/computed expression integer. Same problem. All right. So this is probably that it doesn't know what a computed expression integer is inside float, and probably vice versa. So computed expression integer, I should pound include computed expression float.hpp. And then computed expression. Which one am I in? I'm in integer right now, so let's open float. And there we go. And this is in, oh, it doesn't know computed expression error. I need to pound include that. Should give me the same thing in the integer. Now it's not working, but that's okay. Believe it or not, we're getting closer. So I can't use computed expression integer. That's in program.cpp. So let's go there. Right, and it's still saying it's an incomplete type. Okay, and that's in garbage collected.hpp. And that's when it's using the template. Oh, and the test garbage collected. Yay. Hey. And I just want to make sure. So if I say make clean, make watch dash test. I hate that rule. I want to switch it around, test dash watch. There we go. That is it. Let's see where all the changes that we need to do. So we've got 4 untracked files. Makefile stuff, that makes sense. Just removed stuff, and yeah. So I'm going to do add the makefile. They include computed expression.hpp. They include computed expression float. They include computed expression integer. What else? The source, computed expression source, computed expression float, and source computed expression integer, and source program, and test garbage collected. Did I get everything? Yes. And we're going to say move classes of okay. And the last thing I want to do is the exact same thing, but for the AST nodes. There's only 2 of those, I think. And ast.hpp. I'm again going to stop our compiling. And so there we go. Oh, that's the forward definition of program. Don't know why I put it here. Why didn't I just put it in program itself? Not sure. I'll revisit that. Anyway, so we've got an AST node integer, and an AST node float, and an AST node add. Yes. So we've got 3. Excuse me. That's all right. We can do this rather quickly. First of all, we're going to touch our include AST node integer, AST node float, AST node add, source, AST node integer, AST node float, node and AST node add. All right. We've gotten pretty fast at this, I think. AST node integer. We're going to yank out 27. No, delete 27. There we go. And edit AST node integer. AST node integer. There we go. We know we got to do this. Again, there might be a faster way, but if indef tang st node integer hpp this would be, I know we're gonna need that. I don't think I like calling it AST. It should be AST node, but okay. I'll worry about that at another time probably. That should all be fine now. st node float. It's probably another 27. It is. All right, that one's in place, and now the AST node add. All right, that should be all of those parts. And now oh, gotta do all of the source ast.cpp. And I'm going to do it like this. There may be more. Well, there will be more that needs to be done. for each one of these. So this is integer dump and compile and make copy. Integer. There we go. Yes. Now the float is also dump, compile, and make copy. And then the last one, dump, compile, and copy for node add. That just looks weird. It's because of the particular width. Oh well, that's fine. Now, our makefile. And again, we've got these. So we've got AST and what do we've got? Integer, float, and add. So node add, AST node float, and AST node integer. Now we just have to make the object file one. So let's see. I don't like how big these are. I'm thinking there's a better way. I just have to think about it. Node add, and this is going to be AST node add, and include AST node add, and obviously it includes all the other stuff. Oh. Node float, node float, and right, and then the last one, I think we're almost done. Of course, I know I'm going to have to go back and pound include stuff since I've broken these out into their own files. Okay, that's not going to catch me by surprise. Okay. Not gonna like it, but well, yeah. Opcode's not been declared in node add. That makes sense. Now let's just do the. That's in the source AST node add. Okay, same with node float. And bitcats and node float, so that's going to be the pound include bit. And AST node integer, but I'm also going to go back and edit source/AST because we no longer need bit. And I don't think we need opcode in this one. Probably don't need. We don't need this Tang unused either, which means we don't need macros. And still node integer. So, oh, I haven't edited that one yet. Oh, and bitcast. And it all built. That's always a good thing. Just try to check my diffs really quick. This all looks like what I was expecting. Make file include AST include no, should be source/AST include AST node add include AST node float include AST node integer, source AST node add, source AST node float, and source AST node integer. Make sure I got everything. What wording did I use before? Move child classes of whatever. All right. There's a lot of typing there at the end. And let's see, what was that? That was... oh boy, just eyeballing it. 30 minutes, I think, of moving files around. But you know what? Sometimes you got to do that. You have to refactor code. You have to move it around and to get better organized. Because trust me, if we look at, for example, the source directory, we're going to have a lot more than this. And those files will get unwieldy. You say, Corey, that's because you're using Vim. No, they will get unwieldy despite whatever editor you're using or whatever IDE you're using. So, yeah, you just have to make sure. It's like carpentry, right? You clean up as you go. Otherwise, it gets dangerous. Same thing with coding. Clean up as you go. All right, so let's finish this. Let's say git. So we're done. So git push origin master, and we are now going to tag this with episode. What is this episode? I always have to look. 14. See, I was about to call it 13. Episode 014. And the message will also be 014. Oh no, I forgot to update the documentation. Oops. That's all right. I'll get it done. But that's why you don't code tired. You make mistakes. That's all right. We'll get it in there. But you know what? Hey, we've got our code in better shape, and we've got error messages, which are going to be huge later on. And yeah, I'll just leave it at that. We'll pick up again. Next time we will look at... I hope I don't have to do any more refactoring. If so, it will be... I'll try to spread it out. I won't do it all in one big push here. But... or I may do it and tell you what I did afterwards, just to save you the trauma of watching me do it. But I do know I want to get on and finish out the mathematical operators. And what are the mathematical operators? Addition, well, we've got that. But addition, subtraction, multiplication, division, and modulo. And then after that, so this isn't just next time. I'm saying that's going to take, I don't know, if we get in a rhythm, we might be able to do it rather quickly. We can see about that. But we've got to protect against dividing by 0 and things like that. And modulo by 0. But then after that, we'll probably start adding booleans and our comparison operators. And after that, strings. No. I think we want to do variables first, variable names, and then strings. Yeah, I think that would be good. I don't know. The jury's still out. I'm thinking about it as to which order I want to tackle it in. But, again, making good progress. So thank you again for joining. And hey, have a great day.